After that incredibly long problem, we're going to have to try to wrap things up fairly quickly here with section 1.1. I still have one more video segment here. First, some general principles of how we're proceeding through this process. To solve a system of linear equations, we will apply elementary row operations to the augmented matrix. That's exactly what we did in the preceding example. There are three elementary row operations. One is adding a multiple of one row to another row. The second is multiplying a row by a non-zero constant. The third is interchanging two rows, which we did not use in the preceding example, but that's a pretty straightforward thing. You can just switch two rows around whenever you feel like it in the process. Sometimes that's very convenient. Note that row operations are reversible. That will become an issue a little bit later on for us, but what does that mean? It means that if row operations take us from one matrix A to another matrix B, we can use row operations to go from B back to A. We can always get back to where we started. Also, if one matrix is obtained from another through elementary row operations, we say the two matrices are row equivalent. We'll use that phrase a little bit more as we go through the course. So let's look at one more example, one more problem, and shift this up here. Similar to what we did in the previous video, determine if a system of equations is consistent. If it is, find a solution, and I'll try to proceed a little quicker through this one without being so tedious. In this case, notice that we have x1, x2, x3, so we have three equations in three unknowns, three variables. And let's go ahead and write down what the augmented matrix is. So the coefficient of x1 in the first equation is 0. So I got 0, 1, 5, constant on the right is negative 1. Then 2, 4, negative 4, 6. For my third equation, I have negative 1, negative 1, 7, negative 1. Now, remember how we started out before. We took that first column and we wanted it to look like 1, 0, 0. We wanted a 1 up at the top with zeros below. There are things I could do to get that 0 to be a 1, but I just want to introduce this other thing we can do here of interchanging rows. So I'm actually going to take row 1 and interchange it with row 2 to put that 2 in the upper corner position. So let's go ahead and make that change. So if I interchange those two, I'm now going to have 2, 4, negative 4, 6, 0, 1, 5, negative 1, negative 1, negative 1, 7, negative 1. Realize that as far as the original system's concerned, that's like I just interchanged two of the equations, and there's no reason why one equation has to go before another, so it should seem perfectly okay that we could make this type of a change. Now I want to get a 1 in that position up in the corner, so I have to change row 1. I'm going to take row 1 and replace it with 1/2 row 1, right? I'm just going to divide by 2 so that I get a 1 in that upper left position. I will have to change each entry of row 1 in that same way. So I have 1, 2, negative 2, 3 when I divide by 2. Luckily, they were all even numbers there. 0, 1, 5, negative 1, negative 1, negative 1, 7, negative 1. So I have a 0 at the beginning of the second row, so that's good. That's what I want. But I want to get a 0 now in this third position. Of the first column. And so let's see, I'm going to take row 3 and replace it with row 3 plus row 1. I can just add row 1 to it, and that will give me negative 1 plus 1 is 0. Let's see where we're at then. So recopy, 1, 2, negative 2, 3, 0, 1, 5, negative 1, recopy. Now I'm going to take row 3 and add row 1 to it. So negative 1 plus 1 is 0. I'm going to add 2 to negative 1. Negative 1 plus 2 is 1. 7 plus negative 2 is 5. And negative 1 plus 3 is 2. So next, let's see, I look at my second column. I'm going down diagonally now. I'm not worried about that 2 in the top position of the second column. I want my 1s coming down diagonally. I actually have a 1 now in this middle spot on the second column, but I want a 0 below, right? I want a 1 with a 0 below. So it's this third row that I need to change. Again, row 3, I want to replace with, take row 3 and subtract row 2 from it, I think. That'll do it. One, 2, negative 2, 3, 0, 1, 5, negative 1. That's recopied. It's row 3 that I'm changing. So row 3 minus row 2, 0 minus 0 is 0. 1 minus 1 is 0. That's what I wanted. 5 minus 5 is 0. And 2 minus a negative 1, 2 minus a negative 1 will be 3. Okay, and now you might say, well, I want to get 1s on this diagonal, but if I end up with a 0 here in this position, I'm just going to move over to the right and get, I won't always fall exactly along the diagonal. So I'm just going to take this third column or third row again, and I'm going to replace it with 1/3 row 3. It's actually not necessary. We're about to finish this problem in the next moment. So if we didn't do this step, it would be fine. 1, 2, negative 2, 3, 0, 1, 5, negative 1, 0, 0, 0, 1. What I want to do now is just make an observation about what happens when you have all zeros in the coefficient matrix portion of the augmented matrix. Remember that right-hand column, oops, I'm sorry, I skipped down below again. That right-hand column is the constants from the right-hand sides of the equation. So I just want to make an observation here that because I have all zeros except for that final column position, this stands for saying 0 times x1 plus 0 times x2 plus 0 times x3 equals 1. But that's the same thing as saying 0 equals 1, which is not true, which is impossible. And when you get an impossible equation like this, one other number equals another, that means, therefore, there is no solution. And the system is inconsistent. And really this was already evident at this stage. I guess I could have just stopped there. I don't know why I didn't just stop, because we would have had 0 equals 3 at that point. So if you end up with a row being all zeros except for the last column having a non-zero number, we have to learn to recognize that, because that will be our signal that we have no solution and we have an inconsistent system. That's it. I'm done talking about 1.1. So we will move on to 1.2, either in person or by video. See you soon. Hopefully, I will be in class on Friday for sure, and I will see everyone on Friday. Take care.